Greetings! Welcome to the Devlog for hot dogs, horseshoes, and hand grenades. We're going to start off as always with a quick sound check. Make sure speakers aren't up too high. Wonderful. So what have we got for you this week? Well, as you might have seen in the thumbnail, today's devlog is all about Gameplanner. For those of you who don't know what Gameplanner is, it was an idea I had a couple years back about creating a system of a whole bunch of different interactive objects that could connect to each other. If you've played something like Minecraft, you know what redstone is. That's the general idea. And the whole point of it was to have something in-game that allowed you to make gadgets, contraptions, interactive target sequences, really whatever your kooky mind could come up with. And I had originally tried to make that system work via a sort of event channel signaling system. Had run into a bunch of brick walls, firmly hit the I'm not smart enough to do this sort of stage of it, and had shelved it for a while. Well, because 1.0 is going to be coming out soon, I have returned to it, mainly because I have a collaborator who is smart enough to figure this out. Nathan, author of a whole bunch of the core mod frameworks of the game. He's been working a whole bunch on H3 1.0, and I'd like to present to you the Gameplanner signal system that has been conceived of by him and that we have been plugging into a bunch of the event devices I had made some time ago. So let's take a look at this. I'm gonna show you what these do from a functionality standpoint, and then talk a little bit about how the whole system is going to work and the scope of it. So the basic principle is that we are going to be using a new tool gun that is in the toolbox. For those of you who haven't played with the toolbox, by the way, you just spawn toolbox there, pull this open. This is the pointer tool gun. And at the moment, just so you know, this is not the final way this is going to work. This is going to be a little smoother than what you're going to see here, just so that folks are like, that looks a little annoying. It's still a little rough here. But the idea is, when pointer is out, we can see a bunch of extra geometric shapes around any object in game that's what's called a signals device. So a device that can have inputs and outputs. Right now inputs and outputs look the same. They'll eventually change. I'm actually going to get myself a testing gun here that is nice and quiet to be able to trigger some things. So we're going to get one of the weakest guns in the game. Our underwater pistol. So yeah, so let's play around with this. So let's do something really simple. We have a signals light here, and a signals light has a couple inputs for it. It has an input to set its state, and it is an input to set its color. We can also set its color manually down here. So let's hook something up to this. We have a signals button, and we can use this pistol to basically grab this and connect it to there. Now when we hit this button, boop, boop, the light turns on. Wonderful. We can also grab our signals dial here, and we can connect this up to here, like so. Right now it's red. Now it's green. If we want to delete a line, we click up on the touchpad or BY, delete that connection. We can also connect a switch up to this. Now we can turn the light on, we can change its color, etc. So that's how that works. So we can have manual controls of various kinds going into inputs for objects. We can actually connect multiple ones here. So this input is for the sound that this makes, and then this button will now trigger our event beeper. Oh, interesting. Oh, you know what? I remember now. That's changed under there. Oh, yeah, there we go. Where's the cool sound? There it is. I love that sound. So this should be changing the pitch of this, but it's not, so wouldn't be a devlog without a bug. Oh, now this is changing. It's changing the note. I thought I had wired this up to pitch, but I apparently wired it up to note. So there you go. But obviously manual controls like this aren't the only thing that this can be used for. There are numbers of devices, like targets that will be able to be configured both to have an input and an output. So if we wire up this input over to this target here, and we set it from being spring back mode to not spring back mode, so I can just knock this over now and it doesn't spring back. There we go. If we hit it to on, it stands up. If I hit it to off, it goes down. So I can manually set the state of this target, but I can also wire this up to something else. So if we have, let's momentarily see what sound we're on. Our awesome sound. Awesome. I can actually grab this and pull it over to here, and I could even pull it over to here. And now, when we shoot this target, the sound is so loud we can basically barely hear it. Turn that back on. You probably barely hear it. The metal sound is so loud. Let's see. Let's actually let's pick this up. The wire distances are irrelevant here. There we go. Oops, as I hit myself with my controller. Reset that. Right, let's see if we can hit it from here. There we go. Now we can actually hear the sound that it makes. So this means that in theory, if you wanted to like set up a sequence of targets that all started turned down, and each target when it hits pops the next one up, you'd be able to build that sort of sequence. That, to be convenient, will need a special device we're going to work on specifically called a target sequencer. But you can basically have any sort of device arbitrarily trigger another. There'll be a couple different types of messages that can be sent. These ports can be Boolean, so true or false. They can be integers, like the dial here is sending a number between 0 to 9. I made a couple different dials back in the day with different value ranges. You'll even be able to send things like vector 3s. And it's a super extensible system for anyone who wants to make a mod to make a weird event device that plugs into this. It's like very, very easy and very straightforward. So yeah. So this is the first couple of these devices that we have set up. There's no build yet this week for this because there's, as you can see, like right now I'm having to like actually come in here and like drag this out. That is not good. It's not fun, but it's a little more complicated to do the ray intersections that would allow me to like aim this gun over at that connection, select it, and then drag it onto something, which is what we hope to have working by next week for this. So yeah, I would love to know what you folks think of all of this, and as well as I would just like, especially because it's like been quite a long time since I worked on this, I would love to know from some of you like what you think. You know, we're in the process of authoring, I would call it sort of like 2 core sets of devices to target. There's going to be the stuff that we're going to release early so you folks can stress test this and see if it's buggy and probably make some like terrifyingly complex things. And then there's going to be a set of devices that we're going to release on the 1.0 update. So I would really love if you have any really strong opinions or ideas of like, what about a thing you could plug in that does X to this system? I really want to know what the most requested, most sort of like burning ideas folks have for something like this. So yeah. Well, let's jump out of VR real quick and talk about sort of like the plans for the testing phase of this. Yo! So, a little more about how this whole system works and why this is different from the earlier version I tried to do several years ago. So, the earlier version of this had been based upon this idea of having numeric channels instead of wires. And part of the reason for that is that I had thought at the time it would lower the floor of being able to construct simple devices, like being able to just plug one button into having many different sorts of things happen without having to have all these long wires. And part of that was like, I didn't know how to draw the wires efficiently. And it just seemed like it could be a very convenient thing. And then in the process of developing that, I realized that the biggest problem with having what were functionally invisible implicit connections is that, one, it was very, very difficult to audit what you had constructed. If you had a really complex thing, it was very hard to tell, like, what exactly was connected to everything else. How many things were sending on channel 0? How many things could receive on channel 0? Especially if other things could change what channel something was set to. The other big problem with it, and because it was difficult to audit, it was also difficult to bug fix. The other problem is because of the fact that there, like, many things could speak into channels and receives, there were nasty possibilities for like infinite loops to occur. And there also wasn't really any sort of determinism between the order that many things could occur. In a sense, things would activate and trigger on a given channel, basically in whatever arbitrary order those devices registered themselves into the channel, which could change from scene load to scene load. And so I think a lot of the really sophisticated things that people would have liked to try to make would have had really random behavior in certain circumstances. And so those all put together, those were all of the reasons why back in the day I just sort of like, shelved the whole project, as I realized that I had just a fundamentally flawed design for it. And I did not know nearly enough about math, programming languages, data structures, all the stuff you learn when you get a comp sci degree, which I did not get. I didn't know those things. And so essentially trying to develop a language out of physical objects was not going so well. So thankfully Nathan is here to work with me and explain math concepts to me for this. So this system works via what's called a directed acyclic graph, which means that for any given chunk of items that are wired together, there is a deterministic flow from top to bottom. They will execute in a specific order, and every single object will only ever get updated once per frame, and there can be no loops in it. And so this prevents a whole bunch of like strange corner cases. It does mean that if you want to create a machine that functionally has like looping behavior, meaning it would sort of cycle its state back, we will end up having special modules that effectively receive a signal on one frame and then send out that signal essentially at the top of their graph the next frame. And so you'll be able to control in very specific ways what things are getting 1, 2, 3 frames delayed, etc., and where the top of your graph is and the bottom of your graph is, for those of you who are really into that thing. For everyone else who's probably like, I want to make a machine that blows SOSIGs up, you probably won't have to worry about any of if you're like, graph theory, I just want to blow up SOSIGs. Don't worry. You'll be able to just blow up SOSIGs. And the goal of this set is to have a bunch of really fun and playful inputs, have as many of those be physics active as possible, so that and damage receptive as possible, so that if you end up creating like a Rube Goldberg machine that has explosions and guns and things like that as midpoints in that system, as many of the tools as possible should be able to respond to those things as well. So yeah, so that's what the system is. And as I said, our goal is, as long as things go smoothly, next week we will have a build that will have the first number of these objects for you to test and experiment with. So it'll be the stuff that you see here, a couple more objects than that. I'm going to rig up this the sort of signaling system to the targets. The other thing is we're going to be adding a tool panel to the top part of the toolbox that objects that end up having sort of configurable substate to them, you'll be able to configure with that panel. So for anyone who's played around with Redstone, you're like, okay, what about logic gates for the signal, like and, not, or, XOR, etc. So we're going to have a logic gate object that you can then just like, select with the tool panel and then pick which one of the logic gate types you want with it. Nathan, in testing this, has already made like adding machines and things with all sorts of nodes. It's a lot of nodes to do, but you can do it. So it will definitely be Turing complete, for whatever value that is. A Turing complete SOSIG exploding machine. So, but yeah, it feels really fun to have these back and to actually have a system that's like good to work with. And because of the fact that like this system doesn't have like my old like event system had like little UIs on every single object, and then I was dealing with the performance overhead of world space GUIs on every object. There were many angles that it was kind of like a performance problem and a pain in the butt to manage. And this is a cleaner solution. It will be able to scale to significantly higher complexity than the thing I tried to make years ago. So I'm excited about it, and I hope you are too. And yeah, I look forward to, in the same way that I put together just some like still fairly simple, extra spectator tools, and a whole bunch. You really surprised me by making some like really cool images for our holiday contest. I really look forward to seeing what you all can figure out how to, what to do with these ridiculous signal tools. So it'll be fun. Anywho, that's about it for this week. I'm going to get right back into work, and I will see you all next week with a build to play with. Peace.